Okay, 6.8, we're going to be graphing radical functions, so you're going to want a graphing calculator for this. So just graphing a y equals x squared, if I have my an x squared graph should be a parabola or a U shape. So let's go ahead and graph it. So let's say we do -2, -1, 0, 1, and 2. If I plug -2 in, -2 squared is 4. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Remember, you always go left or right, and then up or down. So I go left 2, up 4. Go left 1, up 1, 0, 0. Right 1, up 1. Right 2, up 4. Okay, so now what we're going to be doing is we're going to be finding the inverse of this equation. Okay, and then we're going to be graphing it and shifting it. So if I have my y equals x squared, my inverse, remember, we need to flip our x and y, and then resolve it to get it into y equals mx plus b. So the opposite of squaring is square rooting. So I got y equals the square root of x. So this is what we're going to be graphing today, and then we're going to be shifting it across our graph. Okay, so here is my parent function. This is what my original function should always look like. So I got -2, -1, 0, 1, 2, and 3. Okay, so if I take a negative and put it in my calculator, the square root of a negative number says domain error. That is because I can't have a negative under my square root. It would be imaginary. So I can't do -2. I also can't do -1 because it would also be imaginary. Okay, square root of 0 should be 0. Square root of 1 should be 1. If I type in the square root of 2 and then do my double arrow to get my decimal, I get 1.4. Square root of 3, I get 1.7. Okay, so when I graph it, I do 0, 0. I go right 1, up 1 for 1, 1. I go right 2, up a little bit past 1, right 3, up a little bit past that. So this is my parent function and what we're going to be shifting. Okay, the reason it doesn't have the bottom of the u for the inverse is because we can't include those negative numbers. Okay, so what's going to happen to my parent function when I have a +2 on the outside? If we think back to when we did absolute values, each little number represented something on where it was at. Okay, so if I put in, we're going to do -2, -1, 0, 1, 2, 3, 4. Okay, so in your graphing calculator, you can type this equation in. Just make sure you end, when you type it in, you press your square root button, you press your x, and then you end your parentheses so the +2 is on the outside. Okay, so to be able to, after you type it in, if you press graph, you should get the graph. If you press second and then graph, it will give you this table set for you. So I'm going to fill in this table set based on the table set after I graphed it. So this is the table set you should get. -2 and -1 don't work because you can't have the negatives under your square root. So I'm going to go ahead and graph them. So I got 0, 2, I got 1, 3, I have 2 a little bit above 3, I have 3 a little bit above that, and then 4, 4. So it should look something like this when you graphed it. So if you go back to graph, make sure that it graphs the exact same. It should look like that. Okay, and from my parent function, if I go back, it looks like it shifted up 2. Okay, so if it's on the outside, it's moving up or down. Positive means up. If I would have had a -2, it would have been moving down 2. Okay, so my next one, it's on the inside. So let's do -2, -1, 0, 1, 2, 3, and 4. So I'm going to type this equation in. I'm going to end my parenthesis after the 2 this time so that the 2 is included in the square root. I'm going to press graph, and then I'm going to press second and graph so that I can get my table set. So -2, it looks like it starts off at 0, and then I got 1, 1.4, 1.7, 2, 2.2, and then my 4, I got 2.4. So when I graph it, I got -2, 0, I got -1, 1, 0 a little bit higher than 1, 1 a little bit higher than that, 2, 2, 3 a little bit higher than 2, and then 4 is a little bit higher than that. So it should look something like this when you graphed it. Okay, so this, it is shifting left 2. So remember back to absolute values, if it was inside, it was always left or right, but it was always the opposite of what you think. So +2, you think, I'm going to go right 2, but it's actually left 2. Okay, if it would have been a -2, then we would have gone right 2. So it's the opposite of what you think. My next one, we got a negative on the outside. Okay, so if I do -2, -1, 0, 1, 2, 3, and 4, I'm going to type in my graphing calculator. Make sure you use the negative button, which is below the 3, when you type it in. If you use the minus sign, it will have an error. And then you do the square root of x. You press graph. You press second and then graph to get your table. Okay, so it looks like I have errors at -2, -1, 0, I got 0, -1, -1.4, -1.7, and -2. So I'm starting at 0, 0. I am going right 2, down 1 and a little bit past. I'm going right 3 and a little bit past that, and then right 4, down 2. So if you notice, that's what my new graph looks like. My parent function looked like this. So this time, if there's a negative in front, it's reflecting over your x-axis. So if it's in the front, you reflect over your x-axis, right there. If it's on the inside, we're probably going to be reflecting over our y-axis. So if I type this in my calculator, so y equals the square root of -x, you're going to notice that your graph's mostly on the left side. So when I do values this time, I want more negative values because it's on the left side. I want less errors, and I want more numbers I can actually graph. Okay, so if I press second table, I'm starting at -4, so that is 2, 1.7, 1.4, 1, and 0. So I start at 0, 0. I go left 1, up 1. I go left 2 a little bit above 1. I go left 3 up a little bit past that, and then left 4 up to 2. Okay, so you can see how it's reflecting over your y-axis because your original was this, and this is your y-axis. Okay, if there's a number in front, so if your number in front is bigger than 2, it is going to stretch it this time. So it should get fatter, your points will get farther away. If it's less than 1, so a half, it's going to shrink it. It's going to get smaller, or your points are going to get closer together. So I'm going to do -2, -1, 0, 1, 2, 3, 4. Okay, so I got y equals 2 times the square root of x. If you have a fraction in your graphing calculator, if you type in, like if you're doing the fraction of 1 over 2, type in 1 divided by 2 and then multiply it by that square root of x. Okay, so then I press second and table. So if I start -2 and -1 both have errors. 0 is 0, 1 is 2, I got 2.8, 3.4, or 3.5, and 4, 4. So I start at 0, 0. I go right 1 up 2, so you can see that that point got farther away. I go right 2 up to 2.8, so pretty close to 3, right 3 past 3, and then right 4 up 4. So you can see that it got fatter. So it's stretched by 2. If it was smaller than 1, it would shrink it and compress it. Okay, so A in front. So if A was negative, so if we had a negative A, it would be reflecting over the x. If my A was bigger than 1, it would stretch, so get fatter. If my A is less than 1, it's going to compress it or shrink it. Okay, inside we're moving left and right, so if I have a minus h, we're moving to the right. If I have a plus h, we're moving to the left. Remember, it's always opposite of what you think. Okay, my k on the outside is up or down. If it's a positive k, we are going up. If it is a negative k, we are going down. And then also if we have a negative x, that means it's going to reflect over the y, if you want to add that in. Okay, so describe the transformation. So this -3, remember the inside always moves the opposite direction, so we are actually going right 3. This -1 means we are going down 1. This negative means we're reflecting over the x. And then the 2 tells me I am stretching by 2. The negative tells me my reflection, and then the 2, since it's bigger than 1, is telling me I'm stretching. So if I go in my calculator and graph it, you type in -2 times the square root of x minus 3, end your parentheses, so the minus 3 is in your square root, and then minus 1 should be outside your square root. Okay, this is more on the right side of your graph, so when you do the table, you're going to include more positives, so 3, 4, 5, 6, 7 is what I'm going to be looking at here. So I press second and graph to get my table. So at 3, I got -1, 4, I got -3, -3.8, -4.5, and -5. So I go right 3 down 1, I go right 4 down 3, right 4, 1, 2, 3, 4 down 1, oop, too many, 1, 2, 3, okay, and then 5, 3.8, 6, 4.5, and then 7, -5. So it looks something like that, okay? So when I go backwards and I'm giving you a graph and I say match it with your equation, well, you could graph all of them and see which one matches. Or if we think back to absolute values, this represented h, this represented k. Whenever I pulled my h value out, we always thought the opposite. So the opposite of -3 is +3. My k value is then -1. That should be where my graph starts. Okay, so you can always find your hk and eliminate options based on the fact that your h needs to be negative or positive and your k needs to be negative or positive. Because it was where it started in our v, it's also where we start in these. Okay, so in this situation, my h, I have plus a number. Well, the only number that's not going to change it is going to be 0. So my h is 0 and my k is 5. So that means my graph should be starting at 0, 5 right here. Okay, so transformations here. The +5 means I'm going up 5. The -x means that I am reflecting over the y. The negative in the front means I'm also reflecting over the x. So I'm going to have a double reflection, and I'm also going to be shifting it up 5. So if I type in y equals negative square root of -x, and then we end our parenthesis because the +5 needs to be outside my square root. We graph it. It looks like this graph is more so on the left side, so I want to include more negative numbers when I graph it. So like -6, -5, -4, -3, -2, -1. And then we already have 0. So -6, I got 2.55. I got 2.7 or 2.8. -4, I got 3, I got 3.27, 3.58, and then 4. So I got -1, 4. I have -2, 3.56, so a little bit above 3, and then a little bit below that, -4, 3. So you can kind of see that it's going downward like this. Okay, so you can see that it got shifted up 5, and then we have that double reflection, and my graph started at 0, 5. Okay, this, we are going to rewrite the equation so that it's a little bit easier to graph. So to rewrite this equation, if we look, they both have a GCF of 16. So when I divide the GCF out, remember it goes in the front of my parentheses. So 16 divided by 16 gets me 1. 48 divided by 16 gets me 3. Okay, and the reason that I'm doing this is because now I can take the square root of 16. The square root of 16 is 4, so it is going to come out of the square root because I took the square root of it. And then we still have x plus 3 in here. Okay, this is way easier to graph than something that starts at 48. So this, we are going to stretch by 4, so it should get fatter. And then we're going to shift right 3 when I graph it. Okay, so if I type it in, I type in y equals my new equation, so 4 times the square root of x plus 3. Make sure your plus 3 is in your square root. You graph it. Okay, if I press second in table, I'm going to start mine at -3 and go from there. So I'm going to do -3, -2, -1, 0, 1, and 2. So -3, I got 0, 4, 5.7, 6.9, 8, and 8.9. Okay, so -3, 0, -2, 1, 2, 3, 4. Oops, 1, 2, 3, 4. Come on. -1, 5.7, 1, 2, 3, 4, 5. So a little bit past. Right there. I got 0 pretty close to 7. 1, 2, 3, 4, 5, 6. Okay, so you can kind of see that it's going like this, where it stretched by 4 and then it went, oops, this was supposed to be left 3, my bad. Ha, that's how you can double check. Check your graph, okay, because it goes the opposite direction. Okay, my next one, we're going to find this GCF. Normally it's going to be the number that's in front of that X there. So if I divide 4 out of both of them, we put the 4 in the front of the parentheses. 4 divided by 4 gets me 1. 12 divided by 4 gets me 3. We still got the -5 and the 3 in the front. Square root of 4 is 2, so that 2 is going to pop out of the square root. And we still have the -5 in the back end. When it pops out, we can then multiply it. 3 times 2 gets me 6. Okay, so it is going to stretch by 6. It is going to move right 3 and down 5. So if you check this in your graphing calculator, that should be the direction that it's moving on this one. Okay, my last one. Remember, to write the equation, we need that HK, so I need this point right here where it starts at, so that is -4, 3. So when I type it in, or put it into my equation here, remember we always flip the H value, so right now it's a -4, so it needs to be a +4. And then I have my K value. Okay, so my original parent function looked like this. So somehow it reflected and went the opposite direction, so that it's going downward now. That's a reflection over the X. If I'm reflecting over the X, that means I have to have a negative in front of my equation here. Okay, so you can double check this by typing it in your calculator and seeing if your black graph matches. So double check to make sure that you pick the right numbers and everything.